Okay, 9.5, trapezoids and kites. So, on a trapezoid, okay, we need to talk about some features. A definition of a trapezoid is a quadrilateral with just one pair of parallel sides. So there's only one pair of sides that are parallel in a trapezoid. Okay. One pair of parallel sides. So in order for something to be a trapezoid, you probably need to prove that one set of sides is parallel to each other. Yes?
Yeah.
Okay. So trapezoid, definition, quadrilateral with just one pair of parallel sides. Now, when we did that diagram earlier, did trapezoid fit under anything else besides a,
What?
It was.
Quadrilateral?
yeah, is that the only thing it fit
Yeah,
under?
I didn't even feel like.
Right, it was like its own little category, yeah? Okay, that's what we're talking about separately. So, trapezoids, you have two bases on a trapezoid, okay? And the bases are the sides that are parallel to each other. That's how you identify them, okay? The bases are the parallel sides. Angles that share a base are called base angles. You know, like on an isosceles triangle, I have base angles.
Are they all base angles then?
No, the base angles are the green ones, angles that share a base. So like, yes, they're all base angles, but they're base angles differently, like they have to be
But
grouped together to be base angles. Like, this
Oh, like
is
base
a
angles
set
are
of
pairs
base
of
angles
twos?
and that's a set of base angles.
Oh,
Yes,
like the,
does that make sense?
yeah,
Okay.
I didn't.
Trapezoids have two pairs of base angles, okay? So like the blue is a set of base angles, the green is a set of base angles. That's why. Now in a triangle, you only have one set of base angles, correct? Okay. Sam, you're just gonna like stare into space today? You thinking, what are you doing?
Thinking schools are
Wow. Well, that'd be something you would know.
Okay. So, isosceles trapezoid theorem. Isosceles trapezoid theorem. What does isosceles mean? Two sides are
Equal.
congruent, yes, congruent. Okay, so an isosceles trapezoid theorem says if the quadrilateral is an isosceles trapezoid, that means the base sides are not the ones that are isosceles, it's the other two sides, okay? If it is an isosceles trapezoid, then each pair of base angles is congruent, meaning angle A and angle B would be congruent, and then angle C and angle D would be congruent with each other. Each set of base angles are congruent, which makes sense because on an isosceles triangle, what do you know about the base angles? They're congruent, okay? You have base angles theorem and you have isosceles triangle theorem where the isosceles triangle proves the base angles are theorem or the base angles prove that the sides are congruent, yes? Okay, so what are the other three angles in this trapezoid here? Let's say that it is an isosceles trapezoid.
102.
What's 102?
Q?
PQ.
Q, PQS or angle Q, yes. Okay, what else? What is angle R and angle S?
Wait,
100 and 200.
58. No, 78.
Both of them, yes. Okay, so we can start to solve stuff, it's pretty simple and straightforward, yes?
Do they have to equal?
How much does it have to equal? Yeah, because how many triangles would be in a trapezoid? Two. Okay. Isosceles trapezoid diagonals theorem. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So, if this side and this side are congruent, it's an isosceles trapezoid, meaning this diagonal AC and this diagonal BD are congruent. So then I can start proving that when two triangles are congruent, their corresponding parts are congruent, I can start doing some stuff with that, yes? Because I would also know that these base angles are congruent, yes? Okay, you get lots of fun triangles going on. I have a big one here, a big one here, I've got this smaller one there, one here, one here. So you're gonna really have to start highlighting stuff to pick out what you're looking for. Okay, so if ABCD is an isosceles trapezoid, then AC, segment AC is congruent to segment BD. Wow.
So can you have trapezoids that aren't isosceles
Correct.
and they'll tell you?
They'll label it as
Show them.
isosceles or they'll have, hash marks on it for you to know, yes? Or the base angles will be marked as congruent, and that's how you'll know. Okay? Okay, mid-segments and trapezoids. More rules. All of these things are rules that come with, algebra behind it. A trapezoid's mid-segment is parallel to each base. So, a mid-segment means what? What do you think it means?
Middle.
A middle of what?
Line.
Trapezoid. Segment.
Middle line trapezoid segment, okay. So it's gonna be the midpoint of both sides connected together to create that midline, yes?
Wait, you said it makes it, yeah.
So this mid segment is the midpoint of line AD and the midpoint of BC connected together to make the mid segment. So if I want to find a mid segment, what do you think I need to use?
Midpoint formula.
Midpoint formula. Or you have to use the distance formula if that's not possible, which it should be, and then divide that distance in half, yes? To find the sum. Okay, but anyhow, this mid-segment is always parallel to each base. Okay, so what happens is, I then create two smaller trapezoids going on here, yes? Okay,
Wait, hold the phone. What's going on?
when you put in your mid-segment, you actually create two smaller trapezoids.
Why would you need to use that?
Because, we'll talk about it in a little bit, I'll show you
To
reasons
figure out
why.
stuff, right?
Okay, the other rule is a mid-segment's length, here's why, Abby. A mid-segment's length is 1/2 the sum of the base lengths. So if I add DC and AB together and divide them by 2, I get the length of EF. So if I know 2 of the 3, I can always find the third. Okay, the top base and the bottom base added together divided by 2 gives me the length of the mid-segment.
These are both the same theorem.
Yeah, they're named the
They're
same
named,
thing,
yeah.
yeah.
It's like, in the last chapter, it had like, situation 1. and
Right. Okay. So that actually makes it nice because then I can start to solve for lengths of things and without using distance formula and stuff. Put your hand down, Kanan.
I was waiting, like 2 seconds.
Okay, so the bases added together divided by 2 gives you the mid-segment length. Base lengths added together divided by 2 gives you the mid-segment length. Okay, so mid-segments and trapezoids. In this trapezoid above, AB is half of CD. What is EF? How do I figure that out?
Wait,
Do
AB.
CD
Oh.
or is equal to 1/2.
Yes.
Whatever that is.
triple AB
plus
to get
that.
EF.
And
So CD is 4 equals what? 1/2 of what?
1/2 of AB and
Well, what's AB?
2.
2, because it says it's half of CD, plus EF, correct?
Yes.
Now what do you do?
Multiply by 2.
Multiply by both sides by 2, you get 8 equals 2 plus EF, yes?
subtract
Then what? Subtract,
6 equals yes.
show me work.
I could do all that.
Okay, so if you have 2, you can find the third, yes? Questions on that, anything, any questions there?
No.
Okay, kites,
We're gonna make a kite.
we are gonna make kites, this is an important chapter for you.
I love kites. They're
Okay,
so cool.
kites, here's how you clarify or decide if something is a kite, okay?
Oh, it's like a map.
Its diagonals are perpendicular. So this from A to D and from B to C have to be perpendicular. They have to create a 90-degree
So
angle.
it's a rhombus.
Would it fit
Yes.
into a rhombus?
Yes.
No.
And only angles formed by the unequal sides are congruent. only angles formed
Where's
by
this?
the unequal sides are congruent.
Where's this in the notes?
What does that mean by unequal sides?
Look, see
I found
angle
it, never
B
mind.
and say, see
Oh.
angle C, they're congruent. Because they are formed by AC and DC, unequal sides,
Oh, okay,
okay?
yeah.
DB and AB form that angle of B. So those angles are the ones that are congruent. A and D do not have to be congruent, just B and C
So it's
are.
diagonal,
But
so if it's a kite, if it's
ABB
diagonals are
and
perpendicular, and if, the angles,
The angles are congruent when they are formed by two unequal sides, because see here, C and A and B and A are equal, yes? So they form, that doesn't mean that that angle is not congruent
Uh-huh.
to that angle down there.
but A and C and D are unequal and their angles are congruent, therefore it's a kite.
No,
No,
angle C is congruent to angle B.
okay,
So side AC and side CD make angle C.
wait, say that again?
Side AC
Mm-hmm,
and side CD
yeah,
make angle C,
yes,
okay? And because AC and CD are not congruent,
mm-hmm,
okay? That makes angle C congruent with angle B, because AB and BD make angle B.
yeah,
And they are not congruent, those side lengths, correct?
yeah,
So those two angles become congruent,
okay. I think I get it.
okay? Okay. I think that's the same thing, yes, its diagonals are perpendicular, only angles formed by the unequal sides are congruent. So in the center, you can create a square out of that segment, yes? And you can start to prove things from it, okay? If you notice on kites, BD and CD in this case are congruent, and AB and AC are also congruent. On traditional kites, that's how it will look, always. Those parts will be congruent. So look here, I have a triangle here, yes? A triangle here, I have a triangle here, and a triangle here. If I can prove that this triangle and this triangle are congruent, which I can, how could I prove those?
Reflexive and then
Reflexive,
you
okay.
can do angle, and so then you have, no, you can't. Not
Do you
like that.
have angle, side?
You have angles, you have angle side side. like
You
both
have-
ways.
You have angle, side,
Uh-huh, or angle side,
or like this, you mean?
yeah.
Yeah. You could do side, angle, side, if you can prove that those bisect in the center, yes. Okay, so there's lots of ways to start proving that triangles are congruent within there. Okay. So then, what is the measure of angle CBA?
90 degrees.
No,
No, you just do 90 for 47.
why 43?
Cause you know angle A is 90 degrees.
Yep.
And then you add it to 47, subtract by 1.
Good,
I thought we were finding.
so 43. So then what would the,
Would it be 33? Oh, never mind, it is 43.
okay. So what do you think the whole of angle B would be?
43 plus
86.
Logically, you would say 86, yes?
Oh,
But
no, it's not.
No,
But you don't know that for sure, do you?
it's not an
No.
angle bisector.
Trick question.
Yeah.
So you do 40.
So don't assume, right? Okay, the only thing we know about these larger triangles right now is that this is 90 degrees, and that this angle here does not equal this angle here. That's all we know. Okay, so I couldn't really solve anything else from there. Does that make sense? Okay, so don't get tricked up if they ask you stuff like that. Now, let's do some homework.